History often paints the invention process as a flash of pure inspiration. The reality is much messier. Progress usually begins when an experiment fails, and the person running it decides to investigate the failure. We are going to trace 6 discoveries born from complete accidents, starting with everyday office supplies and scaling up to devices that sustain human life. Anyone can make a mistake. Recognizing the value in that mistake requires a prepared mind. At 3M, Dr. Spencer Silver was tasked with developing an ultra-strong industrial adhesive. He failed. He created an acrylic formulation of tiny spheres with minimal surface contact. It peeled off effortlessly. Later, Art Fry remembered this weak adhesive. His bookmarks kept falling out of his hymnal. He realized Silver's chemical could anchor a bookmark, leaving the paper undamaged. Internal skeptics at 3M doubted consumers would buy a reusable sticky note. It took years of advocacy and a targeted sampling campaign before the Boise Blitz proved 90% of people who tried them would actually buy them. By shifting the context of a failed bond, 3M turned an industrial error into a product found in offices and homes in over 150 countries. In 1903, the French scientist Edouard Benedictus knocked a glass flask off his desk. He watched it hit the floor, and while the glass spiderwebbed with cracks, it stubbornly held its original shape. The flask had previously contained cellulose nitrate, a liquid plastic. The liquid had evaporated, leaving a thin, transparent film coating the interior that gripped the broken shards. This observation led to laminated safety glass, providing shatter-resistant lenses for World War I gas masks and windshields in early motor cars. In 1938, DuPont's Roy Plunkett was attempting to synthesize a new refrigerant gas. He chilled a cylinder of gas overnight. The next morning, the cylinder weighed the same as before. It was clearly full, but when he opened the valve, nothing came out. After sawing the cylinder open, Plunkett found a strange white powder. The gas had polymerized into a solid that was heat-resistant, chemically inert, and virtually frictionless. These unintended chemical reactions formed physical barriers that eventually protected humans in both industrial kitchens and active combat. In 1895, Wilhelm Roentgen was conducting an experiment by running electric currents through cathode ray tubes enclosed in thick black cardboard. In the pitch-black room, he noticed a barium platinocyanide screen placed several feet away was glowing. Roentgen deduced that an unknown radiation, which he named X-rays, was passing straight through the cardboard. He soon realized they could penetrate solid wood, aluminum, and human flesh, capturing the shadows of the bones in his wife's hand. This radiation provided the first method to see through human flesh and diagnose internal injuries without a single surgical incision. This accidental glow in a dark laboratory provided doctors with a view into the living body that was previously impossible. Alexander Fleming was studying Staphylococci bacteria in 1928. Returning from a vacation, he found a petri dish contaminated with a specific penicillium mold. Surrounding the mold was a clear rim where the bacteria had been completely destroyed. Fleming published his observation, but extracting the active ingredient proved difficult. He lacked the chemistry background to stabilize the compound, and the discovery sat largely dormant for over a decade. It required a dedicated team led by Howard Florey and Ernst Chain to figure out how to purify and mass-produce the antibiotic to treat soldiers during World War II. By recognizing the territorial defense mechanism of a common mold, scientists developed the first reliable cure for systemic bacterial infections. In the late 1950s, Wilson Greatbatch was attempting to build an oscillator circuit to record the sounds of the human heart. While assembling the device, he accidentally installed a resistor with the wrong resistance value. The circuit began to give off a steady, repeating electrical pulse. Greatbatch recognized that the misfire perfectly mimicked a human heartbeat. He pivoted from recording sounds to building a small, implantable device that could actively regulate a failing heart. A simple box of mixed-up electrical components resulted in a technology that currently keeps millions of human hearts beating. We have traced a path from a weak yellow bookmark and a shattered flask to an implanted electrical pulse keeping a heart alive. Countless people drop glassware, mix the wrong chemicals, or solder the wrong parts every single day without leaving a mark on history. These technologies only exist because when an experiment failed, a researcher chose to investigate the anomaly rather than discard the mistake. If you enjoy stories about the hidden history behind the world around us, share this video with a friend who appreciates a good fact.
Share this with someone who loves fun facts.